What's up guys, it's Kevin here again, and today we're going to be covering something interesting. We're going to talk about how to make an object move in random directions. Now, if any of you guys know about like certain games where they can make like, a part or a model or so move within like a ring, but move randomly. You want it to be auto-generated. You don't want to have it move in the same directions every time. We're going to be covering how to make certain like objects, models, and things like that move in random directions, and make them smooth, and move within a barrier. I'll be talking about that too, which is super important. Before we get into any of this stuff, I want to, tell you guys about my Discord and everything. So I have a Discord for my game, The Floor is Sand. It'd be cool if you guys joined. It's kind of small right now, but that's okay. We have a lot of cool people that, that are super active. Like we got some serious supporters of the new game mode, especially of fidget spinners. We got anyways, maybe don't join my Discord, I don't know. Okay, but yeah, so back to the thing. I'm going to show you guys what I mean by objects moving in random directions. We're going to click play, and then we're going to see what happens. This little cool thing that I created. So as you guys can see, there are 10 fidget spinners. Now if you notice, these fidget spinners are moving in random directions. In fact, they're auto-generated. I didn't have like a pre-node path for each fidget spinner. And not only that, they're bouncing off the walls, which is interesting. How do we make a object bounce off walls and program that into its C-framing? Well, we're going to cover that today. Alright, okay. So what you guys first are going to do is you guys are going to go, open a new Roblox studio and everything. We're going to close out of that. We're going to save, okay. And then, okay, so in your, new Roblox studio, you're going to click new. We're going to create a new project, and we're just going to make something very, very basic. What you guys are going to want to do is first we're going to create our ring. Okay, and to do so, we just go over to part. We create a cylinder. Okay, now our cylinder is going to be obviously just placed arbitrarily and on the side. I find it easier, instead of using the tools to edit it, we're going to go into the properties and just change everything manually. So you want it to be centered, so we're going to go in the position. We're going to go 0, 0, 0. Okay, the thing is though is that as you guys can see, whenever you put 0, we're talking about the center of this object, so half of it's going to be under the base plate, which isn't good, but that's okay. We're going to talk about how we can fix that. Right now we're going to go into the orientation, and we don't want it on its side. We want it to be facing up like so. So we're going to put 90 degrees for the Z value. We want it to rotate about the Z axis 90 degrees. Alright, now right now we're going to change up the size. We're going to make it, let's just say 20. That's pretty safe. Okay, and we're gonna make it inside a 200 by 200 barrier. Now you guys can make it whatever size you want. It's gonna look like this, and then we're gonna move it up. Now to do this calculation, the size or the height is 20. So what we're going to have to do is we're going to take that number, we're going to divide it by 2, so we have 10, and we're going to make that the height or the position of this object. Now once we do that, as you guys can see, it is no longer in the base plate, which is exactly what we want. Alright, so we're going to name that outer cylinder. You can name it whatever you want. So we're going to name that outer cylinder. Now to create the barrier, we first have to anchor this, don't forget, and then turn on can collide. All that good stuff, and then let's duplicate this. So we're going to do Control D and make sure you're selected on the cylinder. We're going to duplicate it. Okay, and we get another cylinder. Let's make this inner cylinder. Okay, now what we want to do is we want to edit the size of this inner cylinder. We're going to make it a bit smaller because we want to create a barrier. Ultimately what we're going to do is we're going to union the two parts together. So we're going to do 190. Okay, and as you guys can see, it cuts in. Yeah, you guys barely can see that. Let's actually make it bigger. We'll make it 30. because we don't want the union to mess up and not cut things out. As you guys can see, whenever we resize, it resizes based on the middle, so it goes lower too as well, which is nice. So right here, what we're going to do is after we do that, we're going to go into our properties. We're going to go into model. Sorry, we're going to go into model. We're going to make sure that we select the inner cylinder, and we're going to click negate. Okay, after we click negate, then we're going to control select the outer cylinder, so we select both of them at the same time. Now remember, to select two things, you just do control, and you can select multiple things at once. Like I can select the base plate as well and select everything, but we don't want that. So after we do that, what we're going to do is we're going to union it, and as you guys can see, it cuts straight through. We're going to make sure our union is anchored and can collide is turned on, which is all good stuff. Okay, and you guys can make it, you know, brick color, whatever you want, it doesn't matter. Alright, now what we're going to want to do is we're going to want to create our model. Okay, so let's just make something simple. Let's just, you know, let's create, we'll just make a block for now. We gotta make something more interesting. We'll put a, okay, maybe we'll make a human. Alright, we'll just like scale this up a bit, maybe. I don't know, scale it up, maybe something like that. Actually, you know, screw it. We're gonna go into our toolbox, find some random model. I don't know, let's do something random. We don't want to do another fidget spinner. This is kind of boring. Let's make it like let me think. Do they have anything like yeah, maybe we get a Team 10. Yeah. Maybe some low gang in there. Okay, yeah, let's get a Jake Paul. So we're gonna get a Jake Paul for our model. I know this is kind of yeah, this is kind of awesome because we all love Jake Paul. So we're gonna put in our workspace. Alrighty, alright, let's take a look. Mannequin. Yeah, he's got some pretty basic crap, whatever, you know, pretty boring. But we gotta figure out, we gotta make a primary part for this model. Now remember, anytime we want to make edits to this model, we gotta make sure that we have it to find primary parts. So first, what we're gonna do is I'm gonna just ungroup all this stuff, and then just keep ungrouping it because, you know, this is kind of, you know, maybe we'll take his clothes off. Okay, maybe not. That's some white pasty stuff. Okay, we're going to insert another part. Let's insert a random block. Okay, we're gonna resize this block to, let's just say something easy like 1, 1,1. Pretty basic stuff. Now we want to move it directly to the center of this object, I guess. So we're just going to go to the head and copy the position. So we're going to copy the position of this, Control C, and then go over to the part that we just made, and we're going to paste it in here. And yeah, so the positioning is right in his head, but we don't want, it kind of looks messed up, so we're going to make the transparency 1. Okay, and there you have it. We got our Jake Paul model. Let's put this part inside the model, and then let's make it the primary part. So let's call it primary for now, just so we don't forget it. Click on model. We're going to click primary part, and then we're going to click primary. So now it should highlight white. That's how you know it's the primary part of everything. So now that we got our nice looking slick Jake Paul, okay, we're going to call it Jake. Alright, and then what we're going to want to do is we're going to actually put this little guy in server storage. Now what you put in server storage is basically models and stuff that you want your server to store and everything. We're going to turn on filtering enabled just because it's a good habit to have. But yeah, so we're going to want to put Jake Paul in server storage so that we can replicate it and clone it and stuff for later, all that good stuff. Okay, so right now we have our union, we have our Jake Pauls, so we can get started. Alright, so what we're going to do is we're going to go into server script service, and we're going to insert our script. We're going to call this script, let's just call it like main move, or just call it main, you know, pretty basic stuff. Okay, so before we do anything, we want to start, let's just set up some basic constants. So we're going to do local, and then we're going to do speed. Alright, so we do it in all caps because it just makes it easier to know that this is what's supposed to be kept constant, or like game constants and stuff. It's a good habit to have. We're just gonna make it, we'll make it 10. All right, and then we'll have a local, we'll have the Jake amount. Okay, again, these are game constants. This one will tell us how many Jakes we're going to spawn into the game. All right, so let's create, a function called spawn Jacobs. So we're gonna do local function, okay, spawn Jake. All right, and then so this function is basically going to spawn a bunch of Jakes in it. And so we're gonna do local temp Jake is equal to well, we're gonna go into our server storage. So it's going to be game dot server storage dot and then Jake. So pretty basic. We're just getting the Jake model, and then we're just going to clone it over and over again. So we're going to do for x is equal to 1 comma Jake amount comma 1 do. Now what this does is it basically just loops around, starts at 1, then goes to the amount of Jakes we want, which we defined up here, and then it's just going to do this loop over and over again. You guys know what for loops are, I hope. It's pretty basic. You guys can look up tutorials on what that is and things like that. So what we're going to do now is we're going to have temp Jake. We're actually going to rename this, sorry, we're just going to rename this to Jake original, and we're going to have a local temp Jake is equal to Jake clone. Okay, now this is important. So Jake clone means that what we're doing is we're taking this model Jake, okay, that we defined as in the server storage, and we're cloning it. We're saying, hey, let's make another Jake, okay, we're going to call it temp Jake, who cares, whatever, not a bad name, okay? And so our temporary Jake is going to be a clone. Now what we want is we want to spawn this temporary Jake within the actual game. So we have to change the parent. So we're going to do temp Jake dot parent is equal to game dot workspace. Okay, so this should spawn it into the workspace. You can also create folders and stuff to keep your workspace organized, whatever, but this is super basic, so I'm not going to do that. Now what we're going to do is we want to move it to the correct location. So what we're going to end up doing is we're going to call the function temp Jake and then move to. Okay, now this might be kind of goofy. You guys are probably like, oh my god, Kevin, no, what the heck does move to mean? And move to is basically you're just moving it to a position. You're moving it based off of the primary part. So we're going to take temp Jake move to, and then we'll just have move it to vector 3. So remember, move to requires a vector 3 argument, and we're going to base it off of x, right? So we want it spaced about let's just say 10 studs apart. So we're gonna have 10 times x. All right, but because there's about 10 Jakes, we want it centered. So we'll have like maybe Jake amount divided by 2. Okay, so we'll have Jake amount divided by 2, and then have 10 times that. Okay, so minus, and then plus that. So what this does is it takes 10x. We could simplify this actually, basic math. We'll just make it like they're both multiples of 10, so we can just have it have like 10 times something like x minus Jake amount, whatever, over 2, and then put that in parentheses times 10. Pretty basic stuff. If you guys are into math and everything, this should make sense. So what we're doing is we're just subtracting the Jake amount over 2, and then we're multiplying it by 10. So, and I'm getting a red line for some reason, don't really know why. Oh, that's why we need an asterisk, forgot. Okay, so now what we want is we want the height to be, let's just say 3, and then 0. We don't want to mess with the z value. So here we have it. So this should spawn in all the jakes and everything, and we can test this out by just calling the function spawn jake, and then let's run this just to make sure. And there you have it. So we have a bunch of nice looking jake boys. Yo, what's up? How you doing? How you doing? Oh man, I think I messed up his face. You know what? Yeah, I don't know. Okay, what? Who cares? Who cares? Whatever. He looks better like that, anyways. Okay. Now what we're gonna have is we're going to have local function, and then we're going to move each jake. Now the problem is that if you notice, whenever we spawn in the jakes, they all have the same name. So we gotta fix that up. We gotta change their names, make their names unique. So what we're gonna do is we're gonna do temp jake dot name is going to equal to jake, and then dot dot. This the 2 dots means concatenating, which means adding on to the string. So we're just gonna add on x. So it'll be like jake 1, jake 2, jake 3, jake 4, and yada yada yada. You know, same old stuff. All right. Okay. So we're gonna have this called move jake, this new function. All right. So this new function, what we're gonna do is we're gonna do for x is equal to 1, comma jake amount again, comma 1 do. All right. So we're basically getting all the jakes, and then what we want to do is we want to spawn a function. If you guys don't know what spawning is, it basically adds in a new thread and runs in the background, so it doesn't take up any time. It does take up time. It runs through as if this for loop were just running like really fast. There's no wait time in between here. It is called at the same time as this is called, if that makes sense. It's called threading. You guys can look into that on your own time. What this is cool is if I do something like wait 1, it would only and then do something like print test. It would print it immediately. So let's actually do that just so you guys have a better idea. You would think if I didn't have a spawn function, it would wait 10 seconds because the jake amount is 10. It would wait 10 seconds, then print test, but because we spawn the function, it uses threading, so it's basically waiting all at the same time. It spawns a function, and they all are worked out concurrently during runtime. So let's click play, and boom, it prints out tests. You don't need to wait. And so that's an important thing about spawning, is that you can spawn stuff and things will run concurrently, which is very powerful. Okay, so now what we're going to do is we're going to want to get the fidget, or not the fidget spinner, sorry, I'm getting things confused. We're going to get the temp jake. So we're going to say local temp jake is equal to game.workspace, and then we're going to do find first child. Okay, find first child, and we're gonna find jake and then concatenate the x. Okay, pretty basic stuff. Like we talked about here, that's the name. We're just doing the same thing, concatenating, so we don't have to list out jake 1, jake 2, jake 3. It's a waste of time. And so right now we can actually define a lot of things, which is awesome. So we're gonna do local. Position. Okay, is equal to temp jake dot primary part dot position. Okay, this is super important because we want to record the current position of the temporary jake and base off our velocity off of that. So now what we're going to do is we're going to do local velocity is equal to vector 2 dot new, and then we're going to say the velocity is going to be jake speed comma 0. Okay, so what we're doing right here is we're just creating an arbitrary velocity for jake. Its starting speed is just gonna be jake speed comma 0. Pretty basic stuff. That's how fast the speed will be. Now I know some of you guys are like, oh, what the heck, this is There's, you know, too spooky, 5 me, I don't know, whatever. Well, this is interesting because what we can do is we can manipulate this velocity and make it point in random directions. And I'll explain a little bit more of that a little later. Let me just get all this code written down so you guys can understand what I'm talking about. So let's do this. So we're going to do while wait. So this is going to run forever. Do. Now what you guys can do is you can have like a local, you know, let's just say like a variable, like a bool value. You can be like Jake can move is equal to true, and so we can do while wait Jake can move okay, do, and then we can have like a wait statement in here. What this does is it allows us to wait so that the while loop will run, and it'll wait just a little bit of time and then keep running and iterating over and over again. So now what we're going to do is we're going to do something interesting. Now there's two ways to approach this. So when I was doing the fidget spinner and everything, I've made it so that the let's just spawn Jake into here. I made it so that the fidget spinner would move in random directions, completely random, as in its velocity can go from let's just say this direction. That's a bad way to, let me use the move tool. The velocity can go this direction, right, really quickly, but then it can all of a sudden change directions more than more than 90 degrees, so it can go backwards really fast. And so what it looked like was it was just spazzing out in front of me, which is not what I wanted. Now, I'm going to show you guys what that looks like. So we're going to go back into main. Now you would want to think that to make the velocity random, we would just do velocity is equal to, you know, vector or velocity is equal to vector 2 dot new, and then we just have like a math dot random, let's just do something 10, you know, divided by 10, comma, math dot random 10 divided by 10. And what this does is it chooses a random number between negative 10 and 10 for the x and y values for its velocity. And so this is what I thought would be the best way, is to just make the velocity completely random, and I'll show you guys why this causes problems. So what we're going to do right now is we're going to actually go in and make it so that the Jake Paul, so we're going to do temp Jake, alright, and we're going to we're just going to move to. We're going to use the move to today. I don't really feel like using C-framing. We could do that, but not really feeling it. We're going to do move to, even though it's a lot weaker, but doesn't matter. So we're going to do new, and then we're going to do, you know, position dot x, comma position dot y, comma position comma position dot z. Okay, and we're gonna copy and paste this actually so that we keep getting the temporary part position over and over again. And now we got to add the velocity value. So we're gonna do velocity dot x and then plus velocity dot y. Okay, now we're gonna see what happens when we spawn the Jakes, and we're gonna wait 1 second just to make sure that they're all spawned in, and then we're gonna move the Jakes. Alright, so we're gonna click play, and if you guys notice, they all start moving, but look what happens. They're all like just spazzing. They're not exactly moving the way that we wanted. Now obviously they're gonna move up and stuff because the models intersect. Maybe we're going to have to use C-framing. We're just gonna use some basic C-framing, so let's just do some stuff like we'll do set primary C-frame, or set primary part C-frame is equal to C-frame dot new. Now this should do the trick. Same idea. So okay, alright, okay. See, what the heck? Wait, why? And why do I have hair on my head? I don't have hair. think someone's been editing my avatar. That's a bit odd. That's actually kind of spooky. I don't. Why do I have ultra fabulous hair? Ooh, I know why. I think it's because there's a script in the Jakes. You know, some hacking going on, but that's okay. Whatever. Doesn't matter. The hair is not that big of a deal. So obviously this C-framing is causing us trouble. So what we're just going to do is we're just going to use quaternions. I made a video on how to use those. Now this is overcomplicating things, but I find it super simple to use. We're just going to do make it quaternion friendly. So let's see if I can do this off the top of my head. So we're going to do math dot, I believe it's math dot sine and then angle. We're just gonna do like, you know, math dot pi, pretty basic angle, because we don't want it rotating about the x-axis. We don't want it rotating about the y-axis really either, so we're gonna make that 0. And then we don't really want it to rotate about the z-axis. Let's just make something basic like math dot sine, and then let's just do like 180 degrees. By the way, math.pi means 180, if you guys didn't know. That's just in radians. Okay, and then we're going to multiply that by 1, and then we're going to do math.cosine, and then the angle again, math.pi is the angle, and we're dividing that angle by 2. So after we set that up, it says I got some whack commas. This is the problem. Nope, that wasn't the problem. Was it? What was that, Kevin? Oh, there we go. Okay. Let's click play. Alright, yeah. You know, they're doing their thing. Okay. I have a feeling that these objects aren't anchored. And so they're kind of just doing that. So we're going to go in, make sure that all the objects are anchored. So we're going to go through head to ultra fabulous hair, and we're going to select all. So there we go. And then we're going to make it all anchored. Yeah, it's not anchored. We're going to turn off can collide for this. Yeah, that should do it. Let's make sure that, okay, we're good here. Let's delete the script. I don't know why that's there, some goofy stuff. We're gonna delete the animate script too. Okay, alright, so no scripts in there, which is perfect. There we go. Okay, yeah, so they're all upside down, you know, doing their thing. And that's because we rotated about the z-axis, but it doesn't really matter. We're just gonna keep them upside down. Alright, so we're gonna click pause. So you guys see the problem where they're just spazzing out. They don't really move fluidly. We want them to move really nice and fluid, and so we can't do this. We can't make the velocity completely random. And this was an interesting topic that I was thinking of whenever creating my game mode. I couldn't make the fidget spinners move completely random. And so instead of making the velocity go in random directions, what I had is I restricted it so that the velocity could only turn no more than 15 degrees. Now, if that doesn't make sense to you guys, basically what that means is if I were, let's just say, a part here, okay, I would not be able to change my velocity and go like, crap, one second, and go like from here. I would not, so like let's just say my velocity is going this way, let's just say it's going like in the y direction right here. Alright, so it's going up, okay. I would not be able to turn more than 30 degrees, like in a car. So if I go up, I wouldn't be able to turn immediately right. And so the reason why I'm doing this is because it makes it look more fluid when the object can only turn within 30 degrees. So like move in squiggle lines, things like that, move more fluidly, looks a lot more smooth, because no object is going to have a turn radius of like 180 degrees. Like I'm not going to be able to go forward and then zoom, go backwards. That would just look weird and too unpredictable for a player to register. So we're going to delete this, get rid of that, you know, crap. And then what we're going to do is we're going to set up an interesting thing called a matrix. Okay, it's going to be called our rotation matrix. Okay, so we're going to say x prime is equal to velocity dot x times math dot cosine change angle minus velocity dot y times math dot sine change angle. Okay, now obviously we haven't defined change angle or x prime yet. We will in just a second, and we're going to do z prime is equal to velocity dot x times math dot sine change angle minus, or plus, my bad, plus velocity dot y times math dot cosine change angle. Okay, now this is really important. This is what we called our rotation matrix. That's all that we're doing, is we're creating a new x and z velocity based off of our current velocity. All right, it's gonna look like that. Pretty basic stuff. Nothing, too amazing. And let's just define our change angle right here outside of the while loop. So we're going to do local change angle, and we're going to say it's equal to 0. To start off with, we just want our change angle to be equal to 0. Nothing too spooky. But then over here, what we're going to actually time out here, buddy. I'm getting too ahead of myself. Why not just define it in the while loop and make it easier? All right. Because the change angle is going to change constantly. Alright, so we're going to have, the change angle is basically the turning angle, so how far the thing is going to turn. We're going to make it random, we're going to make it within 15 degrees. So the change angle can only be within 15 degrees. Now we have to convert this to radians, so we're just going to multiply by math.pi over 180. This is basic stuff. If you guys have taken pre-calculus, you can look that up. Conversion from radians to degrees and degrees to radians and stuff like that. Really basic things. We know that it just starts with the idea is that we know 360 degrees is equal to 2 pi radians. And so to convert, obviously we just divide 2 pi over 360. We get pi over 180, and that's how we go from degrees to radians. Pretty basic stuff. So okay, so now that we have our change angle, we have to define z prime and x prime. Again, pretty basic numbers. Don't really need to know a lot of math to understand that. We're just going to define them right here, just so that they're local variables. Alright, there we go, boys. Okay, so now what we're going to do is we are going to take all this stuff, all of our new knowledge, okay, and we're going to set up a we're going to make velocity, we're going to change our velocity vector, and we're going to make it equal to vector 2 dot new, and then we're going to make it x prime comma z prime. So that's our new velocity vector, because what we're doing is we're saying, hey, yo, here's a change angle. We're gonna make it negative 15 to 15 degrees. Okay, so the change angle in our object's velocity can only be between negative 15 and 15 degrees. All right, pretty basic stuff. All right, then we take the change angle and we put it inside this matrix, this angle changing matrix. Now you guys can look up matrices or rotation matrices to get a better idea of what that is, but here's just the basic equation to change any two-dimensional velocity vector a certain angle. Alright, so we take the x prime, okay, and we take the velocity dot x, the original velocity dot x, we multiply it by cosine, all this basic stuff, and you guys are probably wondering why this is z prime. That's because we're going to convert it to vector 3 very soon, because we have to add in the position. So let's actually move this up a bit here. Okay, so it's nice and readable. So now that we have our new velocity, what we're going to want to do is we're going to set the CFrame. and we're going to add velocity.x and then velocity.y, basically x prime and z prime. So let's click play and see what that looks like. So as you guys can see, the Jake Pauls move in random directions. They all kind of flew off the board, and they're going off, off to college, hopefully. But yeah, so they're all doing their thing. But the problem is they are moving randomly. Let's make it a bit slower actually. So we're gonna go up, change it. They are moving randomly, but they're not moving within my border. And even if they're both, even if the border thing is can collide, they're just gonna slip out and do their thing. They do whatever they want because they're gangsters and stuff. And there's 10 of them, which is hard to keep track of. Yeah, 10. Yeah, it's almost like a team. Like, okay, I'll stop. All right, okay. So what we're gonna do is we're going to go in and we're gonna make sure that the velocity or the position stays within the boundary. So we're gonna say position.x. Okay, we're gonna say plus velocity.x. Okay, times, and we're gonna use some some good old math here. .x plus velocity.x. So we're squaring it basically. That's we're basically just squaring it. Okay, and then same thing over here. We're gonna copy this actually because I don't want to retype it. And then we're gonna, instead of having x, we're gonna do y. So we're gonna do oh my bad, z actually. See, this is where it gets kind of confusing because velocity is 2-dimensional but position is 3-dimensional. So we're gonna have velocity.y and position.z. Okay, now what we're gonna do is we're gonna say if that is greater than let's just say 90 okay, so we know that our union thing is about 200 studs wide, but the inner one is about like 95, I believe. So we're just gonna make it 90 squared. So times 90. Now this is the Pythagorean theorem, if you guys didn't know that. All we're saying is if position x squared plus position z, or like this new position squared, we're saying if that's greater than 90 times 90, then that means that it's outside of the union. So this is hard to explain because it does take relative understanding of the Pythagorean theorem, but I'm sure most of you guys will understand that. If not, you guys can look up what the Pythagorean theorem is. This is pretty basic math. I know I might be going a little too fast for some of you, but just bear with me. This is just the condition that you want. Now, instead of having 90 times 90, it would be nice if we just had a variable at top. So we're going to set another constant. We're going to say boundary. Okay. And we're going to make that 90. Alright, so our boundaries are going to be 90. So we're going to do boundary times boundary. Alright. So what this is doing is it's saying, yo, if you are out of bounds, well, the problem is if we add our velocity to our position and it's out of bounds, this is a problem. We want to redirect you. We have to change the velocity. Okay, we have to change x prime and z prime. So we got to figure this out. How are we going to make it so that the part bounces off the union? Okay, now we don't want it to just be some arbitrary thing where every time it hits the thing, hits the union, it'll go in like the same exact direction. Like if we want to hit the union and have it bounce back, we don't want to do that. We want to make it look realistic. So like we want to make it bounce off the union. Okay, whoops, sorry. We want to make it bounce off the union and come at the same angle it was going at it. So it would go like that. You see that? So like that. So like that. So if I hit it straight on, it would come back. So if you guys didn't notice this already, what it is doing is it's basically hitting the tangent of this circle. So let's say we have an imaginary wall. This is like another math lesson. Jesus Christ. Okay, this is a math lesson, guys. We're just gonna do a math lesson. I'm tired of this. We're gonna have to. We have no choice. All right. So we're going to scale this up. You guys don't need to do this. I'm just showing this for demonstration purposes. So this would be an example of a tangent. Okay, so this is a tangent line. All right, now if this is our model, okay, and it's running into the wall, we want it to bounce off that tangent line. We want it to bounce off this tangent line like so, right? Now we just have to think of this as a tangent line. So the tangent line is based off of you know, obviously the surface of the sphere, but also at what point on the sphere that this object is hitting. Now we don't want it to reflect off this tangent line if the object is hitting at this part of the union. So what we're gonna have to do is we're gonna have to calculate this tangent line. We're gonna have to calculate the angle at which this is striking the wall, and then we're gonna have to shoot it back at that same angle. All right, so it's gonna look something like this. All right, so let me see if I can actually draw the math for you guys. 1 second. All right, boys. So that's our, Jesus Christ. Okay, there we go. This is much nicer. Okay. So imagine that this is our union or our barrier, and this is the tangent. Okay. Now notice that let's just say this is the radius right here, and it goes to the center of the circle right here, center. So let's just say center. Okay. And so as you guys can see, this tangent, okay, will make a right angle always. Will always, okay, that square is supposed to represent a right angle, but I can't rotate it. I probably can't. Oh freaking, oh man. All right, it doesn't matter. It doesn't even matter. Okay, it doesn't even matter. So this means that it's a right angle. So this angle right here is gonna be right angle. This angle right here is gonna be 90 degrees. Okay, and so let's just say our little object is right here. And this is distracting, so we're gonna actually let's see if we can delete this. Okay, we can't. life is hard, but we can't. So we're gonna have an arrow, and let's just say, why, man? Why is the arrow not go? Okay, let's just say this is the arrow. All right, so this ball is going straight at the wall to that tangent right there. Okay, you guys can see that, right? So it's gonna bounce off this, okay, and then it's gonna come back and bounce off this way. All right, so that's how it's gonna hit the wall. It's gonna hit the wall right here, and it's gonna bounce off that way. Now if you guys didn't know anything about physics or anything like that, I don't know, you guys are probably smart, who knows, I don't know who watches my videos, whatever. Alright, this angle right here is going to be the same angle as that angle. Alright, so these angles are the same, meaning that this velocity vector, alright, will have to change by this angle. Now if you guys remember, we already have a rotation matrix, so we can just take this vector right here and basically rotate it about this thing right here. Now it's a little bit complicated. It's actually, this is what the vector looks like, and we have to get this angle right here, but we know that this angle is just 180 degrees minus 2 of these angles. Alright, so all we got to figure out is what this angle is, okay, which isn't too hard. Alright, now you guys are probably like, oh my god, you know, Kevin, math, death, kill me. And I'm like, alright, okay, let's stay focused here. Okay, so what we're going to do is we're going to figure out, we know the center of the union is at the origin. We know it's at 0, 0. Alright, so yeah, it's at 0, 0. All we have to do is just take this number, take the position of the ball right as it hits the wall, okay, and subtract it from each other. And then we immediately have this vector right here. Alright, we already have this vector. If we have this vector right here, then all we have to do is calculate the difference between this vector and this vector. We have to figure out this angle. Now a lot of you guys are already dying right now, but that's okay. Alright, we're going to talk about some vector mathematics. Okay, so this might help a bit. Okay, the dot product just states that A dot B, so vector A dot vector B, is equal to the absolute length or the magnitude of the vector A times the magnitude of vector B times cosine theta. Now this is super important because we can calculate that angle by just isolating theta. Alright, and you can find that to find theta, you just have to use this equation. Should be somewhere here, you know, wiki come to baby. Alright, right here. Cosine theta equals A dot B over, you know, magnitude A times magnitude B, and then we can just do inverse cosine or arc cosine or A cos, and we can find that that's actually pretty easy. So we're gonna go back to our paint. So we're just basically gonna take the dot product between these two angles, okay, or these two vectors. All right, that looks like this vector and this vector. All right, we're just gonna take those two, and then we're gonna take the dot product, and then, you know, figure out cosine theta, and then arc cosine it. Pretty basic stuff. You guys won't have to, you know, I'm gonna write out the code so you guys won't have to actually understand the math, but that's how you find this angle. Then what we're gonna do is we're gonna double the angle, do 180 minus double the angle, and then we're going to transform this velocity vector to this vector so that it bounces off the union like so. Alright, so we're gonna come back here. Alright, and then we're going to start doing the math, the good stuff. So we're going to do local vector. This is going to just be a temporary vector. And we're going to equal, let's just say vector 2 dot new. And then we're going to have it equal to position dot x, comma, position dot z. Now remember how I was telling you guys how we have to find the difference between this and the origin to find the actual vector, or to find this vector right here. Now if you guys didn't know, the difference would just be the same thing, because we're basically subtracting it from the origin. We're just subtracting 0, so we don't actually need to do that. That's just busy work. Alright, so we already have the new vector. Alright, so what we're going to do now is we're going to do local temp velocity is equal to vector 2 dot new, and we're just going to say the current velocity. So velocity dot x, comma, velocity dot y. Alright, here we go. Okay, and so local dot product, and we're just going to take the dot product, you know, like I was telling you, we're just going to do vector, and then we're going to use a sweet method called vector dot and then temp velocity. This returns the dot product between vector right here and temp velocity, so it calculates it for us, which is really nice. I could show you guys how to calculate it, but we don't really. You guys can look that up on your own. It's kind of a waste of time for now, but in the future, if you guys are working with this, you should. So now we're going to try and figure out the temporary theta, or the theta that we need. Now this is going to be math.pi minus. Remember, the reason why we're doing math.pi is because that's the equivalent of 180 degrees. And I was telling you guys, we're subtracting 180 degrees minus 2 times the theta between vector and temporary velocity. Alright, so what we're going to do here is we're going to do math.arc cosine, okay, dot product. So take the dot product, divide, and then we're going to do vector dot magnitude, because we want to take the magnitude, and then times the temp velocity dot magnitude. Okay, and then after we have that, we're going to make sure that our parentheses are closed, and we're going to multiply that by 2. Okay, so now that we have that, boys, we are good to go. Now we just say x prime is equal to temp velocity. Now remember, guys, we have to use this whole entire thing again, and don't forget, we have to use our matrix. Okay, and we're going to instead have temp theta. Okay, instead of change angle, temp theta. Remember, temp theta. Alrighty. Oh yeah, I forgot to mention today's my birthday, and yeah, it doesn't really matter because I'm still gonna make a video for you boys, because we're trying to learn some good stuff here. But yeah, woohoo, happy birthday for me. Anyways, I can't even imagine I'm doing math on my birthday already. What a great life it is. Okay, so anyways, we have, so yeah, so we have it, guys. There you have it. We did the velocity. We figured out the, you know, the matrix, the rotation matrix, and then we corrected the velocity so that it bounces back off the wall if it reaches out of the boundary. So let's click play and watch all the Jake Pauls move around. This will be the best birthday present of my life. Alright, so look, all the freaking Jake Pauls are staying, you know, in the union. They're not moving out, they're moving randomly, you know, they're just chilling, upside down. I might make this a prison, who knows. But yeah, hope you guys enjoyed this video. It's super basic stuff, but it's super cool things that you guys can use. You guys could probably make, you know, who knows, like random movements of objects, things like that. It could be really cool. You guys could make like a whole live market and just have the players move in random positions, and people won't even notice that they're computers. So that is, you know, super awesome possum. And yeah, thank you guys for watching again. Another, you know, Kevolution Productions, and hopefully you guys check out my Discord and stuff, and check out my game. I have, you know, a mode based on this. I already showed you guys. It's fidget spinners and stuff like that. And yeah, have a nice day.